Hello and welcome back. In section 2.2, we look at the idea of subsets. So first we'll start with just a basic definition. So set A is a subset of set B if and only if all elements of A are also elements of set B. The notation, so this would read A is a subset of B. Alright, so we'll take a look at a couple examples. Let's say set P will contain elements 2, 4, 6, and 8. And set V will contain elements 2 and 8. So on this, notice that everything in set V is also contained in set P. So I can say that V is a subset of set P. Notice the order here is important. If I switch it around, it would be false. So if I want to say is not a subset, just like the is not an element, we put a slash through it. So set P is not a subset of set V. To prove this, all I would have to do is show you one element of set P that is not an element of set V. So for example, 4 is an element of P, 4 is not an element of V, and that would be enough of an explanation. Let's look at another example, and this one has a nice little property tied to it as well. Let's see. I'll do W. Actually, that's often used for a set of whole numbers. We'll pick a different one. So set X will contain elements A, B, C, and D. And set Y will contain elements C, B, A, and D. So I'm going to ask you to pause it after I put these questions. The true, false, decide if each of these is true or false. So X is a subset of Y. Y is a subset of X. Go ahead and pause it, try it out. Okay, hopefully you agreed that each of these were true. Every single element of X can be found in set Y, so the first one is true. Every single element in Y can also be found in set X, so the second one is true. And when we have each element as a subset of the other, the reason that that works is that these are equal sets. So that is sort of just a property. If A is a subset of B and B is a subset of A, then A and B have to be equal to one another. So next we talk about the idea of the proper subset. So first off, A has to be a subset of B, and set B contains at least one element that set A does not. So, for example, set A contains elements 1, 2, and 3, and set B contains elements 2, 1, and 3. I can say that A is a subset of B, but I cannot claim proper subset. So A is not a proper subset of B because A is equal to B. But if we have, for example, set L containing elements X and Y and set M containing X, Y, and Z, I can say that L is a subset of M. I can also say that L is a proper subset of set M. So everything found in set L can be found in set M, and set M has at least one additional element, in this case, element Z. At set P, we're going to have set P represent 2, 4, 6, 8, 10, etc. And set S be a set of all X such that X is even and X is in the set of natural numbers. So I'm going to ask you to decide true or false again. P is a subset of set S, P is a proper subset of set S, and vice versa. S is a subset of P, S is a proper subset of P. So go ahead and pause it, look over the sets, and see what you decide. Welcome back. So you might have noticed that set S is just the roster, or I'm sorry, set P is the rostered version of set S. S is the set builder notation. These are exactly the same. So everything in set P can be described as being part of set S. 8 is an even number, and in the set of naturals, any of these fit that category. But if they are equal sets, they cannot be proper subsets of one another. So this one is false because P is equal to S. So similarly here, anything I put in here, come up with an even number that's in the natural, say 74. 74 is also in set P, so this one is still true. This one is false for the same reason as the other. P and S are equal to one another. This next one gets a little bit more conceptual. We'll let set E be the empty set and set F be the set containing X and Y. Is E a subset of set F? Well, if you're to tell me no on this, then you have to find an element of set E that is not found in set F. Since we're not able to do that, this one is a yes. The empty set is a subset of set F. So there's our reasoning. We cannot find an element of E that is not in F. So the empty set is going to be a subset of set F, and really the empty set is going to be a subset of any set for that same reason. Now the next set of examples just helps us work on our notation a little bit. So just watching your symbols. So this one, remember, is an element of. So X is an element of the set containing X, Y, and Z. This one is true. However, if I said set X is an element of the set containing X, Y, and Z, this one would be false. Reason being, X here is an element, and this was listed as a set. Similarly, if they tell us that X is a subset of set X, Y, and Z, this one is false. X is an element, not a set. But if they told us that set X is a subset of X, Y, and Z, this one would be true. We're okay with this. Every element in here can also be found in this set. That one is okay. That one is true. Now, one that they might show us, set X is an element of the set that contains other sets, then it's possible for this to be true. So a set can be made up of other sets. That's possible. This one is true. So then the last idea that we look at in 2.2 is how many distinct subsets exist for a given set. So this we're going to just sort of derive on our own. So set A is going to be the set containing only element lowercase a. So some subsets of A. We've said that the empty set will always be a subset. I could have one that just has element A. And really that's it. There's only those two possibilities. But let's look at bigger possibilities. So set B will contain elements A and B. We could have the empty set. we could have one element at a time, or we could have the whole thing. So we had one element, two subsets, two elements, four different subsets. So set C is going to contain A, B, and C. I'm going to ask you to pause it and create all of the subsets of set C. I would recommend doing it in a more organized fashion like I did here. No elements, one element, two elements at a time, three elements at a time to try to get them all. So go ahead and pause it and unpause when you're done. Welcome back. So we had three elements, the different subsets. So this would be of set A, subsets of set B, subsets of set C. We could have the empty set. We could have one element at a time. So just A, just B, just C. We could have two elements at a time. So maybe A and B together. Maybe A and C together. Maybe B and C together. And maybe we have three elements at a time. So we have 1, 4, 7, 8. 8 subsets. So we'll try one last one and then we'll go for how to know how many subsets there are. So see if you can create all of the subsets for set D.